My name is Kaylen April, and I will be presenting a mathematics lesson which falls under measurement and geometry. This lesson aims to provide an informative explanation of the Theorem of Pythagoras. The outcomes for this lesson is that 1. We will discover the proof of Pythagoras. Then 2. We will calculate some Pythagoras examples. And 3. We will be working through an activity. And 4. We will be applying Pythagoras theorem to real life situations. And 5. We will explore the kite. What you will need for this lesson is a digital device such as a laptop, a tablet, or a cell phone. Then you will need a stable Wi-Fi connection. You will also need Microsoft Word. You will need email, and then also Zoom for our live interactions. Let's go through some history and facts of Pythagoras of Samos. So the Theorem of Pythagoras, which is the theorem we will be studying in this video, was founded by the Greek philosopher and mathematician Pythagoras. He was born around approximately 570 BC in Samos, Greece. He died around approximately 495 BC, which means he died around the age of 75. Pythagoras is also known as the father of numbers. The theorem of Pythagoras forms a basis for trigonometry. The theorem connects geometry and algebra. The ancient Egyptians used what is known as the theorem of Pythagoras today, long before Pythagoras discovered or invented the theorem. Therefore, it is argued whether Pythagoras was really the one who invented the theorem. And if you are wondering how the ancient Egyptians used this theorem, hang on to find out. 1. Let's discover the theorem of Pythagoras, and we will do this by means of a proof. Some basic knowledge that you need for the proof is that you should know the area for a square. The area for a square is length of the square multiplied by the base of the square. And then the triangle labels. The side opposite the right angle symbol is called the hypotenuse. So this is the right angle symbol. The side opposite to it is called the hypotenuse. The sides adjacent to the right angle symbols are called legs. Here's our right angle symbol. The sides adjacent, which is the height and the base, are also referred to as legs.
Let's look at the proof of the theorem of Pythagoras. Now what I'll be doing is, I'll be drawing a triangle with its height being 3 centimeters, its base 4 centimeters, and the hypotenuse here is 5 centimeters. And this is called triangle, which means that that corner is 90 degrees. So what I did was I measured the length, and it was 3 centimeters, and I drew the base. It was 4 centimeters, and the hypotenuse was 5 centimeters. So what the theorem of Pythagoras does is, it explores the relationship between the three sides of a right-angled triangle. What I will do next is, I will attach a square to each side of the triangle. We know that a figure is a square if the sides of the figure is equal and the corners are 90 degrees. Let's attach the squares. So the height is 3 centimeters. So I'm going to draw a line 3 centimeters this way, 3 centimeters there, and when I join them, it is also 3 centimeters. Let's do the same with the base of the triangle. We know that the base is 4 centimeters, so we'll draw a line down 4 centimeters, another line down 4 centimeters, and this line will also be 4 centimeters. Let's attach a square to the hypotenuse. So just going to draw these lines as a guideline. We know that the hypotenuse is 5 centimeters. So we've got 5 centimeters there, 5 centimeters there. And when you join the two, it should be exactly 5 centimeters. So this is 5 centimeters. This is also 5 centimeters, and that's 5 centimeters. We've that area is equals to length multiplied by breadth. I've just colored the squares so that we can differentiate the squares. We know that the area for a square is length times breadth. So let's calculate the area for the pink square. Its length is 3 centimeters and its breadth is 3 centimeters. So therefore, the area of the pink square will be 3 multiplied by 3, which is 9. Let's look at the area for the green square. We've got 4 multiplied by 4, and that is 16. Let's look at the area of the bigger square, which is the blue square. We've got 5 multiplied by 5, and that is 25. What can we notice from between the relationship of the 9, the 16, and the 25? Can you see that 9 plus 16, so the area of the pink block plus the area of the green block, which is 16, is equals to 25, which is the area of the blue block. This is exactly the same as 3 squared plus 4 squared is equals to 5 squared, because 3 squared is equals to 9, 4 squared is equals to 16, and 5 squared is equals to 25. Notice that the 3, 4, and 5 are exactly the same measurements we started off with in the beginning when we measured the height of 3 centimeters, the base of 4 centimeters, and the hypotenuse of 5 centimeters. So this gives us the relationship between the sides of the right angle triangle, which was 3 centimeters, 4 centimeters, and 5 centimeters. 3, 4, and 5, all of them squared. What I've drawn here is a similar figure, but it's not drawn to scale. Let's work with variables instead of using numbers. Let's say the height was A and the base was B and the hypotenuse was C. So now instead of using numbers like the previous example, we're just using variables instead. So similarly in the way that this was 3 centimeters all the way around, let's make this A centimeters or units all the way around. So we've got A, the side of the square would be A, that would be A, and this would also be A. And let's do the same with B. Each side of the square would be B because the sides of a square are equal. And the same with C. Each side of the square is equals to C. Once again, I've colored the squares just to make it easier to explain. Let's look at the pink square. What would be the area of the pink square? That would be A multiplied by A, because once again the area of a square is length times breadth. So we'll have A squared. What would be the area of the green square? That would be B multiplied by B, which is B squared. And what would be the area of the blue square? That would be C multiplied by C, which is C squared. Notice that we have a similar scenario to the one where we drew the measurements, where we actually measured it out. So what we said with this figure was that 9 plus 16 is equals to 25. So in the case of the variables, we'll have A squared plus B squared, which will give us C squared. So the area of the pink square plus the area of the green square will be equals to the area of the blue square. That is A squared plus B squared is equals to C squared. And this right here is where the theorem of Pythagoras comes from. So the formula for the theorem of Pythagoras is C squared is equals to A squared plus B squared. It could be the other way around too. It could have been C squared is equals to B squared plus A squared. Bear in mind that A, B, and C are just placeholders or variables. So this could have been anything else. It could have been Z squared is equals to X squared plus Y squared. It could have been M, N, and O. It could have been any letters or variables. One common error that students make when writing down the formula is that they forget to square the formula. So they usually just write C equals to B plus A. That is not correct. You need to square it because it is in terms of area.
Let's imagine we have 3 blocks of chocolate of different sizes. One very small, one slightly larger, and one which is the biggest piece of chocolate. And we've got 2 people, 1 and 2. How can we equally share these blocks of chocolate between the 2 people? Let's look into it. We looked at the proof earlier, and this is a similar example. So we have formed a 90-degree triangle with the 3 blocks of chocolate. The smallest block is a 3 by 3. So 3 times 3 is 9. The block slightly larger is 4 by 4. So that is 4 multiplied by 4, which is 16. And the largest block is 5 by 5, which is 5 multiplied by 5, which is 25. So what we've got here is that 9 plus 16 equals to 25. But we also know that 9 is the same as 3 squared, 16 is the same as 4 squared, and 25 is the same as 5 squared. If we were to replace these values with A, B, and C, this would bring us back to the proof being C squared is equals to A squared plus B squared. And this is the formula for Pythagoras. In the same way that this would be 3 squared is equals to 4 squared. 3 squared plus 4 squared is equals to 5 squared, which is a 3, 4, 5 triangle. So therefore, person 1 can get these two blocks, and person 2 can get the other block, the bigger block, as the areas are the same. We've got 16 plus 9, which is 25, and which is equal to the bigger block, 25. So far, what have we discovered? We have discovered and established that the formula for the theorem of Pythagoras is a squared plus b squared equals c squared, or c squared equals a squared plus b squared. And the theorem of Pythagoras states that the sum of the squares, the sum which is plus of the squares of the two sides, the squares, here are the squares to the power of 2, of the two sides of a right-angled triangle, which is the height and the base, are equal to the square to the power of 2 of the hypotenuse. And the hypotenuse, which is opposite to the right angle of a triangle, is C. For number 2, let's calculate some Pythagoras examples.
Let's look at the following example. So, you are given a right-angled triangle and you are required to calculate one of the sides of the triangle using the theorem of Pythagoras. The side that is missing is the leg. So, let's look at the formula for the theorem of Pythagoras. It's c squared is equals to a squared plus b squared. So the a and the b are the sides, or the legs of the triangle, which is the height of the base, doesn't matter which one, and the c represents the hypotenuse, which is 29 centimeters. So now let's substitute the values. 29 squared is equals to a squared, which is 21 squared, plus b squared, in this case is x, and it's the one that we're looking for, the unknown variable. The square root of 29 is 841, and the square root, and 29 to the power of 2 is 841, and 21 to the power of 2 is 441, and we're still required to find the value of x. In order to isolate the x squared, we will move the 441 to the left hand side of the equation. So we'll have 841 minus 441. 841 minus 441 is equals to 400. That is equals to x squared. Now let's just arrange it in a way where it makes more sense. Put the x squared on the left hand side. So in order to isolate the x, to get the x alone and to get rid of that square in the exponent, you need to square both sides so that the square root and the square will cancel. And on the left hand side, therefore x will equals to 20 centimeters. That means that the base of this triangle, x, is equals to 20 centimeters. Let's look at the following example. This time you are required to calculate the hypotenuse of the triangle using the Pythagoras theorem if it's given that this corner is 90 degrees. Let's write down our formula. C squared is equals to A squared plus B squared. C squared, if we have to substitute these values, we know that the C is the hypotenuse and the other two legs are A and B. So let's substitute C squared, which is y squared now, is equals to A squared, which is 4 squared plus 7 squared. It doesn't matter which one you substitute into A or B. The result should be the same. So y squared is equals to 4 squared, which is 16. And 7 squared is equals to 49. The sum of 16 and 49 is 65. And we've got y squared on the left hand side. So we need to square both sides in order to get y alone on the left hand side, or to isolate y. And the square root of 65 is approximately 8.6 centimeters. That means that the hypotenuse here is 8.6 centimeters long. That is 8.06, approximately 8.06.
Hi, Bernice. You've indicated to me that you've got about 2 or 3 questions for me.
Hi, Kaylen, April. Yeah, there's just something I need to ask you for some advice. In the exams, I get a bit stressed when I see the questions of Pythagoras. I don't know what to do immediately, or I was hoping you can give me some advice how to approach the question.
So firstly, what you need to do is identify what it is that they are looking for. So essentially what the theorem of Pythagoras is to calculate one of the missing sides of a right angle triangle. So you need to identify in the diagram which side is missing. What I suggest you should do is, firstly, write down the formula. Do you know your formula?
Yeah, it's A squared plus B squared equals to C squared.
Yes, so I suggest with a pencil on the side of your page, you write down the formula immediately, then identify which side is missing and do the necessary substitutions. Does that clarify it for you?
Yeah, that makes it, I understand it better that way. And then there's something else also. In Pythagoras, the wording is a bit difficult to understand when it comes to the word sums or so.
Okay, that can be tricky sometimes. So what you need to do is, I suggest you read the question a few times. So don't just read it once and think that you'll grasp it immediately. Read the scenario a few times until you are able to identify which side is missing. So which side are they asking you to calculate? In that way, you can substitute your values.
And you must okay, and then another concern that I have, sometimes I don't know when to minus, when to plus. I don't know exactly how to use it.
Okay, so if you've got the formula c squared is equals to a squared plus b squared, and you are looking for the hypotenuse, which is c squared, then you are required to plus. So you'll be adding your a squared plus your b squared. And if you are looking for, let's say, a squared, which is the side, one of the legs, either the height or the base, then you're going to say c squared minus b squared is equals to a squared. And the other way around, if you're looking for b squared, then you're going to say c squared minus a squared is equals to b squared. Those are just how you manipulate the formula to suit the question. Does that make sense?
Yeah, it's much clearer to me. Thank you very much.
Thank you, Bernice.
Number 3, let's look at an online activity. For this activity, the instructions are that you are required to complete the multiple choice questions. Then you should fill in the answers on a Word document. Remember to number the answers from 1 to 5. You've got 30 seconds to answer each question. Then send me your solutions to the following email address, u163139126@tux.co.za. Enjoy the quiz. Question 1. What is the length of YZ? Is it A, 9 centimeters, B, 15 centimeters, C, 19 centimeters, or D, 25 centimeters? Your time starts now. Question 2. What is the length of the hypotenuse of triangle RST? Is it A, 8 units, B, the square root of 8 units, C, the square root of 34 units, or D, square root of 14 units? Your time starts now. Question 3. Pythagoras is also known as, is it A, the father of mathematics, B, the father of philosophy, C, the father of numbers, or D, the father of geometry? Your 30 seconds starts now. Question 4. What is the formula for the theorem of Pythagoras? Is it A, C equals to A plus B? Is it B, A squared plus B squared equals to C squared? Is it C, C squared equals to A squared minus B squared? Or is it D, C squared equals to A plus B? Your 30 seconds start now. Your final question, question 5, true or false? For the Pythagoras theorem to be applied, one of the corners of the triangle must be 90 degrees. Is it A, true, or B, false? Your time starts now.
Let's look at an email received by Bernice, one of the learners, for the Theorem of Pythagoras. Your first question, B, that's the correct answer. Your second question, C, that's the correct answer. Your third question, C, that's correct. Your fourth question, B, that's correct. And your final question, A, that's correct. So you received a total of 5 out of 5. This indicates that you are on track. 5 out of 5. Very well done. Keep on practicing and keep up the good work. Earlier in this video, I promised that we would look at how the ancient Egyptians used Pythagoras, or the Theorem of Pythagoras, long before Pythagoras of Samos discovered the theorem. Let's look into it. The Egyptian rope stretchers. So what the ancient Egyptians did was they constructed triangles with 12 equally spaced knots, as we can see in this image here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 knots, which were equally spaced. So between the two knots there were equal spaces. They knew of the 3-4-5 rule, which we know today as the Pythagorean triad, and they created the 90 angle right angle. So what they did was they stood stretching the rope, ensuring that there was 3, 4 and 5 knots in between the people, similar to the 3-4-5 rule by Pythagoras, and that would create a 90-degree angle. The Egyptians used this to ensure that the corners of the base of the pyramids that they built and other buildings were all right angled. They were using the Theorem of Pythagoras approximately 1,500 years before Pythagoras actually discovered the theorem. And today, builders still use the Pythagorean theorem to ensure that their buildings are built in perfect squares. Let's apply Pythagoras to real life by looking at some real life examples.
Let's look at some real life examples of the Theorem of Pythagoras. Here we've got an example of two kids playing on a seesaw. The distance between the two kids is 7.8 centimeters and the length of the seesaw is 8 meters. How high is each child lifted from the ground? So in this case, we are required to calculate how high this child is lifted from the ground, and that would be our 90 degrees because it hits the ground at 90 degrees at a right angle. Firstly, let's identify our triangle. As you can see, here we've got our triangle. So we are looking for the one side of the triangle, the leg. We've got the other leg, and the hypotenuse, which is opposite to the 90 degrees, is 8 meters. Let's call this leg that we are calculating x. Let's write down the formula for Pythagoras, which is c squared plus equals to a squared plus b squared. C squared in this case would be the hypotenuse, which is opposite 90-degree angle, 8 meters squared, and the a squared would be the 7.8 squared, and b squared is what we are looking for, and we named it x, so we have x squared. 8 squared is 64, and 7 squared is 60.84. So now we need to isolate the x. So we'll have to subtract the 60.84 from the 64. And that would give us x squared. So let's just write it in better. 60 minus 64. 64 minus 60.8 is 3.16. In order to isolate the x and to get rid of the exponent, we need to square both sides. So x is equals to the square root of 6, and the square root of 3.16 is 1.78 meters. So the child is lifted 1.78 meters from the ground. What we've got here is a house with a ladder leaning against the house. And we are required to calculate the length of the ladder if the distance between the ladder and the house is 3 meters and the top of the ladder and the ground is 5 meters. You can see that the top of the ladder and the ground is hitting this triangle at 90 degrees. So let's first identify our triangle. It looks something like this with the 90 degrees there. So we have 5 meters here and 3 meters there. We are required to calculate the length of the ladder, which would be the hypotenuse of this triangle, as it is opposite the 90 degrees. So let's use our formula. C squared is equals to A squared plus B squared. C squared, which is what we are looking for, is equals to A squared, which is 3 squared, plus B squared, which is 5 squared. So C squared is equals to 3 squared, which is 9, plus 5 squared is 25. 9 plus 25 is 34. In order to isolate the C, we're going to square both sides so that those two can cancel. So C is equals to the square root of 34, which is 5.83 meters. Our next example, we've got a flagpole and somebody standing at a distance of the flagpole. The length of the flagpole is 30 meters and the distance between the flagpole and the person is 20 meters. Using the theorem of Pythagoras, you are required to calculate the distance between the top of the flagpole and the person. So firstly, we know that our 90 degrees will be there because the flagpole is hitting the ground at 90 degrees, as it is obviously a straight flagpole. Let's look at the answer, the solution. So let's write down our formula. C squared is equals to A squared plus B squared. C squared will be the hypotenuse, which is the side we're looking for. Let's name it x. X squared is equals to A squared, which is any one of the two sides. 20 squared plus B squared, which is 30 squared. So x squared is equals to 20 squared, which is 400, and 30 squared is 900. 400 plus 900 is equals to 1300. So in order to isolate x, we square both sides, and x is equals to the square root of 1300, and that is approximately 36.06 meters. So the distance from the top of the flagpole and the person is 36.06 meters.
5. Exploring the kite and relating this to the theorem of Pythagoras. properties of a kite. The kite is a quadrilateral. What a quadrilateral is a four-sided figure. In the kite ABCD, lines A and B and CD are diagonals in the kite. So A, B, and C, D are diagonals in the kite. The point at which lines AB and CD meet equals 90 degrees, which makes it a right angle. This is the point here at which CD and AB meet. Let's call this point O. The line CD bisects the diagonals AB. So this line CD bisects the diagonal AB. Bisects means to divide it exactly in two. If you look at the word bisects, bi means two, like a bicycle that has two wheels. The line CD bisects, so cuts line AB exactly in half. The line CD bisects the angles C and D. So this line CD bisects this angle D into two exact angles, and here also represented by the two crosses or the two X's. These angles are exactly the same. The line CD bisects the kite into two congruent triangles. So if you had to divide this kite into two, into triangle CAD on the left hand side and CBD on the right hand side, it's congruent because they are exactly the same. Therefore, side AC is equals to side CB. AC, which is this line, is equals to CB. Side AD is equals to side BD. AD is equals to BD. Those two lines are equal. And line OA, we call this one O in the middle, OA is equals to line OB. Remember that the perimeter, what is perimeter? It is the sum of the sides of the kite. So AC plus CB plus BD plus AD is the perimeter of a kite.
Bearing in mind the properties of a kite, let's use the Pythagoras theorem to determine the perimeter of this kite. The perimeter is the sum of the sides of the kite. So AC plus CB plus BD plus AD is equals to the perimeter. The yellow line is the perimeter. We are given that OB is equals to 5 centimeters, which is from the center to B. So this line is 5 centimeters, and OD is equals to 10 centimeters. So O from the center to D, the end of the kite, is 10 centimeters. From the properties of a kite, we also know that this corner is 90 degrees. So what we have in this kite is 4 triangles. And from the properties of a kite, we know that the triangle on the left, which is CAD, triangle CAD, is equals and congruent, the same as the triangle on the right, the bigger triangle on the right, which is CDB. So triangle CAD is equal or the same as or congruent to triangle CBD. This means that if we find the hypotenuse AC, then it means that we know that length will be the same as CB. And if we find the hypotenuse AD of this triangle, then we'll know that AD will be equals to BD. And then we'll be able to calculate the perimeter of the kite. So what I've done here was I've taken out the triangle ACO and drawn it separately. Another given that I've left out was that OC is equals to 5 centimeters. So we've got OC, which is equals to 5 centimeters, the leg of the triangle. The other leg, OA, will be the same as OB, and they've given us OB 5 centimeters. It's the same because CD bisects AB, so therefore AO will be equals to OB. So AO is equals to 5 centimeters, and AC is what we are calculating. So let's call this X. The formula for Pythagoras, C squared equals to A squared plus B squared. So C squared in this case is AC, or X, squared, and A squared is one of the sides, which is 5 squared, and one of the other sides, 5 squared. So we've got 25 plus 25 is equals to X squared. Therefore X squared is equals to 50. So in order to isolate the X squared, we need to square both sides to cancel out the exponent. So therefore the value of X is 5 square root 2, which is approximately equals to 7.0 centimeters, 7.07 centimeters. So now we've calculated AC, because X is the same as AC, which is approximately 7.07 centimeters. So we've got AC being 7.07 centimeters, and on the other side CB will then also be 7.07 centimeters, considering the properties of a kite. Now I've taken out triangle AOD and I've drawn it separately to calculate this part of the kite. The hypotenuse of this part, which is AD, is what we're looking for. Let's call it X. And OA we already have, and that's 5 centimeters. And OD is from there to there, which they've given us. OD is 10 centimeters. Let's calculate the hypotenuse. So AD, or X, C squared, this is the formula for Pythagoras, is equals to A squared plus B squared. C squared, which is X in this case, squared, is equals to A squared, which in this case is 5 squared plus 10 squared, which is OD. This could have been any way around. It could have been 10 squared plus 5 squared. It wouldn't make a difference because it's separated by a plus. And so therefore X squared is equals to 5 squared, which is 25. 10 squared is equals to 100. So X squared is equals to 125. And in order to get rid of the square root, what we need to do is the exponent to the power of 2, we need to square both sides. Therefore the exponent and the root will cancel each other, and we'll have X is equals to the square root of 25, which is 5 square root 5, which is approximately 11.18 centimeters. So therefore say that BD is also equals to approximately equals to 11.18 centimeters. So what we've discovered was that AD, which is what we were calculating, is 11.18 centimeters, and BD is also 11.18 centimeters, considering the properties of a kite. But we have not yet fully answered the question, because they asked us to calculate the perimeter of the kite. So the perimeter of the kite would be 7.07 plus 7.07 plus 11.18 plus 11.18 was simply 11.18 multiplied by 2 plus 7.07 multiplied by 2. So I've multiplied the 7.07 by 2 and the 11.18 by 2, and the answer is, and added them together, so the answer is 36.44 centimeters. And that is the total perimeter of the kite.
In conclusion, what we covered in this video was the theorem of Pythagoras, and we did this by discovering the proof of Pythagoras and also calculating some of Pythagoras' examples. Then we worked through an activity, and then we looked at some real-life application, and finally we explored the kite by relating it to the theorem. I hope that this video was informative, and this brings us to the end of the theorem of Pythagoras. Thank you.